Hey everyone, I just thought I'd record a quick example of how to complete the activity that we did in class today, since we didn't have as much time as I wished for us to discuss it. So remember, we were focused on evolving one of these characteristics of the tomato. For this example, I'm going to pick something like, let's see, fruit size, since we discussed that one a bit in class. Okay, so we have a wide range of tomatoes. For this particular variety, tend to be very small, about 2 to 3 centimeters in diameter. To show directional selection with this, I'm going to start by drawing this graph to show the distribution of the trait. So we'll say that this is our first starting point. So here on our x-axis would be the different sizes of tomatoes, with very, very large tomatoes, say the size of your hand here, and very tiny ones, pea size down here. So most of the tomatoes for this plant are in the relatively small size. Our y-axis, remember, is frequency or percentage of the population. The next step was to decide on a selective pressure. Well, in this case, I'm going to make the selective pressure a raccoon that favors a particular size of tomato. Okay, so over the years, this group of raccoons tends to come and select all of the largest tomatoes if they're at least 6 to 8 centimeters in diameter. So the largest of the tomatoes that are there, the ones that are almost too large for the whole plant. Okay. What this is going to do is push the population in one direction. In this case, towards smaller and smaller tomatoes, because the largest ones, those seeds are not actually being what's used to reproduce for the tomato in the next generation. Okay, so we have the selective pressure being the consumption by the raccoon, okay, eating the large tomatoes. Those seeds don't grow in the next generation, so it should push the population to smaller and smaller tomatoes. Let's draw a graph of that. So you can see here that I've drawn the second graph with the most frequent tomato size being much farther to the left of the graph, which was much smaller tomatoes. Okay? It's not so much about the height of the line on the graph. Remember, that's just frequency. So say this is 70% of the population. This is also 70% of the population. That's not what we changed. What we changed is where the particular trait is that is most common. So here it was a larger tomato than in our future generation after evolution. Remember, in class we represented this with arrows going up and down as far as what was more common or less common in the subsequent generations. So if we do the same thing here, we would only have positive selection for these smallest tomatoes, and we have selection against these much larger tomatoes that were favored by the predators. You could do this with any scenario and with any of the different types of selection that we've discussed.